Sorting and searching algorithms. There are three different algorithms. There's the bubble sort, the quick sort for searching, and the binary search for searching. Just a hint, if you have an alphabetical list to sort, it's worth writing out the letters you've got before you start, just to make sure that you've got your alphabetical order right. So, bubble sort first of all. Things that you must show each pass. You don't need to show the bubbles that you're sorting, you don't need to show each step of the first pass, but you must show the full pass at the end. You must also, for a bubble sort, include your stop sentence, which is, there are no more swaps, so the list is in order. There will be a mark for that stop sentence on the bubble sort. At the end of each pass, count the number of items to check that you've not missed any. Bubble sort is something that is very common where people miss out a number or they write it twice. So just double check that number at the end of each pass. And on the final pass, check back against your original list to make sure you've not miscopied at any point. People often write 27 as a 72, reversing the numbers, or they record something twice, or they miss out one number. So just do a check that the numbers in your final pass agree with the original list on the exam paper. For the quick sort, show a pivot with a circle and something that's fixed with a line underneath it. You must have a key for the quick sort. There will be a mark for the key. So you just write circle, pivot, underline, fixed. All pivots become fixed in the next line down, so each number must have a circle and then in the next line down followed by a line underneath it. For single items, for the Edexcel mark scheme, they need to be pivoted and then fixed in the next line. So a single item, don't just leave it, make sure that it's been pivoted and then fixed. The stop sentence for a quick sort is just that all items are now fixed. There isn't usually a mark for this in the Edexcel mark scheme, but it's probably worth including anyway. And then again, like the bubble sort, check your final list against the initial list to make sure that you've not miscopied any of the numbers at any point. At the end of both the bubble sort and the quick sort, and in fact at the beginning, make sure that you've checked whether the list needs to be in ascending or descending order. Ascending order is usually the easiest. If it's given in descending order, that's where people often make errors. So check it once at the beginning and check again at the end, is it ascending or descending? The next type of search you get is a binary search. So the binary search is for locating items in a list. Your list must be in alphabetical order to use this, or numerical order. So just make sure that you are doing it on an alphabetical or numerical ordered list. On the first line, write out the list that you're given in the question and give a number to each item in your list. And these are the numbers that you're going to refer to when you find your pivots. For binary search, you must show the calculation for each pivot. So for example, the first pivot for this list will be the first value plus the last value, 1 plus 6, divided by 2, gives me 3.5, always round up, so the fourth item will be the pivot, and then write this by name so it's clear that your pivot for the first pass is J. You must then also include a statement to say that you're rejecting part of the list. So your reject statement would say reject J and either left or right depending on which side you want. You must reject the pivot each time. No sticky pivots are allowed, so reject the pivot and one side of the list. Having written this statement, you then show your next pivot calculation. You go back to the numbers that are recorded here. So if I've rejected J and to the left, I'm left with M and P, which are the 5th and 6th numbers. So my pivot is found by adding the first number in the list plus the second number in the list, again divided by 2, so my pivot for the next pass will be the 6th, and record the letter or the number, so that's P. And then again you do your reject statement and then note show your next pivot and so on. You don't need to write out the new list each time, but you do need to make sure that you've said which part of the list you are rejecting. Your final statement for a binary search is to say whether or not you have found your item. So if your item is in the list, your final statement will be that you've found the pivot is P, so P is located. So if you're searching for P, once you get it as a pivot, you need to write so P is located and in the list. If your item isn't in the list, you need to keep going until you get an empty list. So 6th is P, so I reject P and to the left. So on this list, P and to the left is the rest of the list. And I need to then say the list is now empty. So Y is not in the list, and I need this sentence to say that I've got an empty list. You will occasionally get asked questions about the number of swaps or number of iterations that you need to do. So always use numerical reasoning. You can do it in general terms, you can do fancy formulae, but the mark scheme will always accept that you've done a numerical reasoning where you've listed all the different possibilities, and this is usually the easiest method. So for a binary search, for example, if there are 26 items in the list, you need to look at the maximum number of letters at the start of each iteration and make sure that's clear what you're doing. So you start with 26, you'll reject half the list, which will be 13, so the next iteration down you'll be left with 13. You'll then reject the pivot plus half the list, so the pivot will be in the 7th position and reject 6, so I'll be left with 6 in the list. And then when I've got 6 in the list, the next line down I'll reject 3 of them, so I'll be left with 3, and then the next line down I'll be left with 1. Stop at 1 and then count how many iterations you've got, including the starting iteration, and that's the maximum number of iterations required. For a quick sort, you might be asked to look at the number of comparisons in a pass, or potentially all together. So looking at the number of comparisons in a pass, each item that is not a pivot or a fixed needs to be compared. So there's 3 comparisons on this side, 3 comparisons on this side, so therefore you get 6 comparisons. If you've got more than one pivot, same principle applies. It's a number of items that are not fixed and not a pivot. The worst case scenario is that you get 1 pivot per line. So in the first line you'd get n-1 swaps, and it would reduce by 1 each time. And again, a numerical argument with each line of the working is the easiest way to do this. For a bubble sort, the number of swaps, on the first pass it's always n-1 swaps. So if you've got 20 items in your list, the first part there will be 19 swaps, the second pass 18 swaps, 17 swaps, and so on, and the final pass, the worst case scenario is just 1 swap or 1 comparison. So again, a numerical reasoning is usually the best. If you've got a lot of numbers to add, remember that you can use your formula for an arithmetic progression to add them more quickly, but if not, just do it by hand.